What is the principle of superposition, and how can you use it to make circuit analysis a little bit easier for yourself? Find out right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering, lecture service.
Alright, so I have three equations here. Here's my 1.5 V delta, which is VB minus VD, and well, that's V delta. Just remember that this value is V delta, and then VA minus VB, and then VA minus VD. And then the second one, this is, so I should put what these are. This represents the currents going away from VA, and these represent the currents going away from VB. And these three here, this is VB minus VA, VB minus VD, VB minus a negative 25. So in this one, what was VC. That's was VC was equal to negative 25 volts. So I've put a 25 over here, a negative 25 in place of this VC. And then of course R1, R3, and R2. And if you look back at the diagram, you'll see that. And then here are the currents going away from VC. So this was minus 1.5. Again, this is V delta. And then VC minus VB, which is minus 25 minus VB over R2, minus VD over R5, which was the current going away from the point at VC. Now, I know on this one we had a ground, but really it's less a ground and more of a reference. So there's no current going in or out of the ground. It's just a reference point. We're calling that point 0. The circuit is fairly standalone. So all the values of the voltages in the circuit are going to be what they are, referenced to that 0. Less than that, they're going to be referenced to each other. More than that, they're going to be referenced to each other. So the current, as I said, going away from that point at VC was minus VD divided by R5, or 0 minus VD. So I wrote these, this of course is Mathcad Professional, and you can see I'm using Mathcad to determine these. I could just do this by hand. If I put numbers in for R1, R2, and then just solve for VA, VB, and VD, then we'll have a nice little thing there, but I don't want to do all that. So what I did is I plugged this into a solve equation in Mathcad, and I said find VA, VB, and VD, and it gave me these three formulas right here. Here's VA is equal to that, and VB is equal to this, and VD is equal to this. Alright, so once we put that in, the next step of course is going to be to plug these in and get some numbers. So when I did that, okay, so I put values in, copied and pasted those values, R1, R2, R3, R4, and R5, and this is running in Mathcad, so Mathcad will solve all of these problems. All you have to do is put these values in, you plug in the formulas, and VA. Notice now I'm not calling this VA, I'm calling it VA1, VB1, and VD1. Now why is that? Remember, we're doing a superposition problem here. And a superposition says that if you calculate without the power supply, the one power supply, and then calculate without the other power supply, and then add the two values up, you should get the same as with the two power supplies present. So what this is doing, it's simplifying the problem a little bit more, and it's more importantly, it's telling you what part of the voltage is supplied by this power supply. So here we have VA1 is going to be 7.434. Now Mathcad will also do this in volts, and it'll actually get all your units correct for you, or if you don't have correct units, it'll come back and say, hey, your units aren't right. but these are volts, 7.343. VB1 is 1. Okay, so I have them down here actually, 1.578, and VD1 is 2.45. These are the contributions to the circuit due to the second power supply, V2. Now you'll notice also that I didn't take the current source, the voltage control current source, out of the circuit, because that's essential to have this thing operating. So let's have a look at when we run this thing in SPICE. And of course, here's our net list, and pull my pen back. Here's our net list, and this is what this is called. This is called a net list. And what the net list is a listing in SPICE of all the devices that you have in the circuit and which nodes they connect to. And once it's basically the way that SPICE works. Now, you can draw schematics and it'll figure that out for you, and that's what we've done here. But you'll notice that in SPICE we have taken this V1 out of the circuit, and we ran an operating point. Remember, the operating point is a DC operating point. And here we know, of course, VC, which is our notice it's minus 5 volts. We knew that because there's a negative voltage right there. What we want to know is VA, VB, and VD. So VA is going to be, let's see, 7.43, which is VE. Now, this apparently it's just skipping. You can see VA and VE are the same. So it said, well, I already know what VA and VE, so we're going to give you the no voltage for VE, which is VA right here, 7.433.5, which is about what we have right here. VB 1.578, and we look at VB and we have 1.578, and VD and we have 2.45, and that's what we have here is 2.45. So SPICE program has correctly come up and identified it agrees with our calculations and our equations. So that is the first half of getting this part, VA, or we want to know VB and VD. But right now we only have the first half. So what do we have to do now? We have to do the next part. So the next part is, of course, back to my pen, we have the same circuit, but now we're going to remove, here is V2 is gone. Alright, so now we've taken out our power supply, V2, our voltage source, and we've replaced it with a short circuit. And now we're going to determine VB and VD with this power supply missing. It's going to simplify. And of course, again, you can see there's a net list right here. A listing of all the components and their nodes. Now, so for this second part, we're going to work around nodes VA, VB, and VD. Alright, so let's start with VA. We're looking at the currents away. So the first one, of course, is this one again. It's going to be 1.5 V delta plus VA minus VB again. That's VA. I know it looks like a VB. Minus VB over R1 plus VA. Now we've got a little problem here. We're going to say this is V1 minus V1 because we're going from positive down to negative. We're subtracting a voltage minus VD all divided by R4. This is all equal to 0. Okay.
Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.